Friends, welcome to Dipole Moment. So the learning objectives of this video are understanding dipole moment, its formula and unit, dipole moment as a vector quantity, examples of the diatomic, triatomic and the tetraatomic molecules having a dipole moment, applications of the dipole moment. So friends, the dipole moment is the product of the charges and the distance between the center of these charges. Or in other words, we can say that the dipole moment is the measure of the polarity of a bond or the polarity of a molecule. Let's suppose here we have two charges which are denoted by plus Q and minus Q. And you can see here that the distance between these two charges is denoted by small d. So, the dipole moment is denoted by a Greek letter mu, which is equal to the magnitude of the charges into the distance between these charges. Dipole moment as a vector quantity. So as you can see here that the vector quantity having a magnitude and a specific direction. Similarly, the dipole moment have a magnitude and a specific direction pointed towards the more electronegative atom. So friends, as you can see here an arrow. So the dipole moment is denoted by an arrow with a curved tail which is pointed towards the more electronegative atom. So friends, what's about the unit of the dipole moment? The unit of the dipole moment is dBi. As 1 dBi is equal to 3.34 into 10 raised to power minus 30 coulombs meter. Applications of the dipole moment. Dipole moment predict about the polar and the non-polar nature of a molecule. It also measures the polarity of the bond or molecule. It helps in the calculation of the percent ionic character. It also predicts about the molecular geometries and the bond angles. Factors affecting the dipole moment. First is the electronegativity difference. If there is an electronegativity difference between the two atoms of a molecule, then it will result in a dipole moment value. Second is bond pair of electrons with an equal and unequal sharing of electrons. So friends, if we have a bond pair of electrons with equal sharing of electrons, it will result in a zero dipole moment. Whereas, if we have a bond pair of electrons with unequal sharing of electrons, so it will result in some dipole moment value. Third is a lone pair of electrons. Due to this lone pair of electrons, the molecule must have some dipole moment value. Dipole moment of a diatomic molecules. As a diatomic means a molecule of two atoms. So if a molecule having two similar atoms, as in a case of a hydrogen, chlorine and oxygen, so what will be the dipole moment? Imagine two people playing tug and war and both of them having the same energy and both of them pulling the rope from the both sides with equal energy. So what will happen? Who will win? Nobody will win. So what will be the net result? In this case, the net result will be zero. Now look at here, in case of a hydrogen molecule, there is an equal sharing of electrons, so the net dipole moment will be zero. Here, due to the equal sharing of electron, no charge will be there on hydrogen, and as a result there is no polarity of a bond or a molecule. Therefore, this bond is a non-polar covalent bond. Now, in the case of the chlorine, again here is a similar situation arises that the net dipole moment will be zero because of two similar atoms. Now look at here, in case of oxygen, again we have two similar atoms and there is no electronegativity difference present between these two atoms. So as a result, the net dipole moment will be again zero and a molecule is a non-polar molecule. Remember that in case of non-polar molecule, the dipole moment will always be zero. Dipole moment of a diatomic molecules with two dissimilar atoms. Now let us take an example of the hydrogen fluoride. So friends, when we go across the periodic table from left to right, the electronegativity increases. And we know that the hydrogen is the electropositive atom of the periodic table, whereas the fluorine is the most electronegative atom of the periodic table. Now, due to this electronegativity difference, there is an unequal sharing of the electron between the hydrogen and fluorine. As in the tug of war between the two people with an unequal energy, both of them are pulling the rope, but one with more energy will win. Similarly, in case of the hydrogen fluoride, hydrogen is less electronegative as compared to the fluorine. So as a result of this electronegativity difference, the hydrogen having a charge of partial positive, whereas the fluorine having partial negative charge. So what will be the dipole moment in case of the hydrogen fluoride? As we know that the direction of the dipole moment is from the less electronegative atom towards the more electronegative atom. So here this direction is from hydrogen towards the fluorine. As you can see here, this red arrow denotes the dipole moment. Here in case of the hydrogen fluoride, the dipole moment is equal to 1.191 dBi. Now let's discuss the dipole moment in case of the hydrogen chloride. Now look at here in a periodic table that the chlorine is under fluorine. So here the electronegativity is a little bit less as compared to the fluorine, but as compared to the hydrogen, the chlorine is more electronegative. It means that the pulling power of the chlorine is more as compared to the hydrogen, and therefore these electrons will be shifted towards the chlorine, and as a result the dipole moment is equal to 1.03 dBi. Now look at here, as compared to the hydrogen fluoride, the hydrogen chloride having a less dipole moment. Why the hydrogen chloride having a less dipole moment as compared to the hydrogen fluoride? Because of the electronegativity difference between the fluorine and the chlorine. As the chlorine is less electronegative as compared to the fluorine, therefore its dipole moment is less as compared to the hydrogen fluoride. Now let's take another example of the hydrogen iodide. Here, iodine is more electronegative as compared to the hydrogen, so the iodine having a partial negative charge and the hydrogen having a partial positive charge. And the direction of the dipole moment, as you can see by a red arrow, is pointed towards the electronegative iodine. So what will be the dipole moment in case of the hydrogen iodide? It having a dipole moment that is equal to 1.38 dBi. So When we have an electronegativity difference between two atoms, as a result, the dipole moment must have some value, and the molecules in this case must be a polar molecule. It means that the polar molecules having a dipole moment, whereas the non-polar molecules having a zero dipole moment. Dipole moment of a triatomic molecule. Friends, let's take an example of the carbon dioxide. As we know that the oxygen is more electronegative as compared to the carbon, it means that the pulling power of electrons of oxygen is more as compared to the carbon dioxide. To understand it clearly, let us take an example. Imagine that two people playing tug of war and both of them having the same energy. And both of them are pulling the rope from the two opposite sides. So what will be happen? Imagine that these two people are the two oxygens which are on the opposite side. As we know that both the oxygen having the same electronegativity means that they having the same energy. So what will be happen in this case? Who will win? So in this case, both the oxygen having the same energy and these are in opposite direction, so they will cancel out each other effect. So friends, in case of the carbon dioxide, we know that the dipole moment is equal to 0. Why? Because both of them having a same magnitude and is in opposite direction. Therefore, the carbon dioxide is a non-polar molecule having a zero dipole moment. Friends, dipole moment also give us an indication of the structure of the molecule. If you know the magnitude of the dipole moment, you would get an idea about the structure of the molecule. So here in case of the carbon dioxide, as we can see that these two dipole moments are in opposite direction and they cancel out each other effect. As a result, the molecular geometry of the carbon dioxide is linear geometry. And the bond angle here is 180 degrees. Friends, let's discuss the effect of the bond pair of electrons on the dipole moment. Now look at here, if all the bond pair of electrons are there in a molecule with an equal sharing of electrons, so as a result, there will be a no electronegativity difference between the atoms, and in this case, no poles will be found. And the dipole moment in this case must be a zero dipole moment. Now look at here, we take an example of the methane. Here the electrons are equally shared between these four hydrogen atoms. So in case of methane, there is no electronegativity difference. Therefore, no pole formation or no charge formation will formed here. And as a result, the dipole moment in this case is zero dipole moment. And we know that when we have a zero dipole moment, this molecule must be a non-polar molecule. Friends, as you can see in a diagram that at the four corners of the carbon, four hydrogens are attached and they have an equal electronegativity. So you can see here that the hydrogen having a partial positive charge on the four hydrogen atoms. But they will cancel out each other effect because they are with equal strength and in opposite direction. And due to this, they have an equal sharing of electrons which result in no pole formation, and as a result, the molecule having a zero dipole moment, and this molecule is called non-polar molecule. Friends, let's take an example of carbon tetrachloride. Look at here that the carbon is a central atom and at the four corners of the carbon, four chlorines are attached. We know that the chlorine is more electronegative as compared to the carbon. It means that the chlorine pulling power of electron is more as compared to the carbon. So what will be the dipole moment is in case of carbon tetrachloride? Now friends, look at here that the chlorine is attached to the four corners of the carbon. So these will cancel out each other effect. As a result, there will be equal sharing of electrons at the four corners of the carbon because these four chlorine will cancel out each other effect. As a result, this carbon tetrachloride having a zero dipole moment means that it having no polarity or it is a non-polar molecule. And we can also predict the molecular geometry of this molecule by using the dipole moment. So, here the molecular geometry in case of the carbon tetrachloride is tetrahedral molecular geometry and the bond angle is 109.5 degree because of the equal sharing of the electron between the atoms. Let's discuss an unequal sharing of electron which result in the pore formation as in the case of CHCl3. Now look at here that the central carbon is attached to the four atoms that are one hydrogen and the three chlorines. And due to these dissimilar atoms, this result in electronegativity difference which must give some dipole moment value. Friends, remember that if the similar atoms are attached to the central atom, then there will be no electronegativity difference and the net dipole moment will be zero. And if dissimilar atoms are attached to the central atom, as in the case of CHCl3, so it must result in some dipole moment value. Look at here that the dipole moment of CHCl3 is in a downward direction. Now here hydrogen is less electronegative as compared to the chlorine, so the direction is from less electronegative to the more electronegative atom. So here CHCl3 having a dipole moment that is equal to 1.15 dpi and hence a molecule is polar molecule. We can also predict here the molecular geometry and you can see here that at the four corners of an atom, the four bond pairs are attached and as a result, the molecular geometry of a molecule is a tetrahedral and the bond angle here is 109.5 degree. Effect of the lone pair of electrons on the dipole moment. So friends, up till now we have discussed about the effect of the bond pair of electrons with equal or unequal sharing of electrons. Now we will discuss the lone pair electrons effect on the dipole moment. So if we have less number of the bond pair electrons in a molecule means that unequal sharing of electrons will be there in this case, which will result in electronegativity difference, and we know that when there is an electronegativity difference between an atoms, it will form a pore formation, which will result in a dipole moment. So friends, in other words, we can say that if a molecule having a lone pair of electrons, it must have some dipole moment value. Let's take an example of ammonia. Now look at here, in case of the ammonia, we have 3 bond pair and 1 lone pair of electron. And remember that when we have a lone pair of electrons in any molecule, this molecule must have some dipole moment value. So in case of ammonia, the nitrogen is more electronegative as compared to the hydrogen. As you can see that the arrows are pointed towards the nitrogen. But in case here of lone pair, this arrow is pointed in an upward direction because the lone pair showing a high electron density in upward direction. So the net dipole moment value is 1.46 dBi and the direction of the dipole moment is in upward direction. So friends, we also know that the dipole moment also predict about the molecular geometry. As you can see here that the nitrogen is attached to the 3 bond pairs and 1 lone pair of electron. And due to this lone pair of electron, now the molecular geometry is a pyramidal, having a dipole moment of 1.46 dBi and the molecule is a polar molecule. Friends, let's discuss an example of 2 lone pair of electrons in case of a water molecule. So friends, look at here that the oxygen is more electronegative as compared to the hydrogen. So these arrows are pointed in an upward direction. So what will be the resultant dipole moment? Here you can see that we have 2 lone pair of electrons and we know that when we have lone pair of electrons, it must have some dipole moment value. So the dipole moment of the water is equal to 1.46 dBi. We also know that the dipole moment also predict about the molecular geometry. So in case of the water molecule, we have an angular molecular geometry. Look at here, this water molecule gives us an angular molecular geometry. Friends, let's recall key points. More electronegativity difference between the atoms. So the dipole moment must have some value and the molecule is a polar molecule. If there is no electronegativity difference between the atoms, so the resultant dipole moment having a 0 value and a molecule is a non-polar molecule. The bond pair electrons with an equal sharing of electrons result in a 0 dipole moment because of no electronegativity difference between atoms. Bond pair electrons with unequal sharing of electrons having a dipole moment value because of the electronegativity difference between atoms. Friends, remember that the lone pair of electrons in a molecule gives a dipole moment value because of the electronegativity difference. So friends, if this video is really useful for you, then don't forget to like, share and subscribe my channel Digital Chemistry. Thank you.